lines are really a segment, AD, and a line CE that intersect at this point B right here in the middle, okay? So there's our intersection, and because of it, it creates four angles, right? We have angle ABE, we have angle EBD, we have angle DBC, and angle ABC over here, okay? So there's our four angles. Now, if we look closely at the measurements of those angles, which I have in each corner here, you notice that ABE's measurement and CBD's measurement are the same, okay? So I'm going to go ahead and make those two the same color angle, make them both red. Then if you also look closely, you notice that DBE and CBA are also the same. So I'm also going to make them the same color, make them both green, okay? Now that's not a coincidence, and you'll watch as I move and I change the angles. So I'm going to slide this around. So you see the angles change, but the ones across from each other are still the same as each other, no matter what I do to it. Oh, slid that along. Even if I make it really small, you see how even the ones across from each other end up being the same as each other, okay? So no matter what I do, the angles across from each other are equal, okay? So that's called vertical angles. So vertical angles are angles across a common vertex, in this case B. Remember, a vertex is that point of an angle, right? The sharp pointy end of the angle. So vertical angles are across a common vertex, so a vertex they share, and then they're same. Now in geometry, they don't usually use the word the same, they use congruent, okay? So they are called congruent. Congruent is just the geometry term for equal to each other, okay? So they're congruent, they're equal. The congruent symbol is an equal sign with a little wave on top, okay? So vertical angles are across a common vertex and they're congruent. So these two red angles are vertical angles to each other, as well as these two green angles are vertical angles to each other, okay? In your notes, it might be helpful next to vertical angles to draw a little picture and kind of show that that's what vertical angles are, those angles across from each other, okay? And that they're congruent. All right, so on here, if I were to give you that this was 50 degrees, you would actually be able to figure out every other angle on here, all three other angles, okay? So we just talked about vertical angles, so that would mean that this angle over here is also 50 degrees, because you can kind of think of it as a mirror, right? Here's the angle, and if I flip-flop it as a mirror image of it, it would be over here, right? Now, we can also figure out this angle and this angle. They're clearly vertical to each other, so they're going to be the same. But what's going to be helpful with this is what we learned last time. See this nice straight line, or you can look at the other nice straight line. That means that this angle and this angle all together are supplementary. And if you remember, that means they add up to 180. So if I told you that one's 50, that makes this one 130, and this one also 130, okay? So we have two sets of vertical angles. We got the 130 and the 130, so that's one set, and the 50 and the 50. And then we have all kinds of supplementary angles. These two are supplementary to each other. They add up to 180 because they're along this straight line. Same with these two. They add up to 180 because they're along that same straight line, just on the other side. We also have these two are supplementary because they're along this straight line. And these two would also be supplementary because they're also along that same straight line. Okay, drawn all over this. But, so let me give you another example. And see if you can come up with all the missing angles on here. So if I tell you that this is, we'll make it easy. Let's say this is 100 degrees. Go ahead and draw a little quick angle thing. It doesn't have to be perfect. And figure out what these other three angles have to measure. All right, so let's see how you did. So if that's 100, the one across from it is 100 because of vertical angles. Okay, so that's our reason, is that they are vertical. And then the other two each have to be 80. They're the same because they're vertical to each other, but we know it's 80 because it has to be supplementary, which means it adds up to 180 with the other 100. Okay. All right, let's try one more. Draw a quick little 4-angle thing. And let's say this is 32 degrees. Go ahead, pause it, fill in the other measurements, and then hit play. All right, so if that's 32, this is also 32 because of vertical angles. And then if they're 32, then the other one has to be what, 148? It's supplementary with a 32, so this would also be 148. Okay, so that's supplementary and vertical angles. They're really helpful when you have intersecting lines like this, because as long as you know one angle, you can figure out all the other angles. All right, building on the supplementary and vertical, we have this. All right, so let's look at this. First of all, let's ignore, it looks complicated because there's a lot of lines. But let's first just look right here. We got this, and they're intersecting at B. So there's our 4 angles right there like we were just talking about, okay? So they told us that this one up at the top right is 44, okay? So if this one right here is 44, that also makes this one right here 44, so that's 44 degrees. And if they're both 44 degrees, that makes this one right here 136 degrees, right? Because it's along that nice straight line with the 44, so it has to add up to 180. And that means this angle over here is also 136 degrees, okay? So we got all 4 angles around this vertex B. Now, you come down here and you have another vertex C, where this angle right here is also 44 degrees. So what does that mean about the 4 angles here is that they're the exact same thing. That this is also 44, this is also 136, and this is also 136, okay? So that's not coincidental. These are called corresponding angles, okay? And they're corresponding angles because these 2 lines, AE and HF, are parallel to each other, okay? So this symbol right here means parallel. And it's easy to remember because if you look at the word parallel, you can kind of see the symbol right there. There's the symbol. And remember, parallel is 2 lines that do not intersect. Be sure to write down this definition. Remember, intersect is run into each other. So at no point will those 2 lines intersect. It's kind of like railroad tracks, right? They have to be the same distance apart at all times, otherwise the train wheels will snap off, okay? So it's 2 parallel lines, okay? 2 lines that will never intersect. And the reason we know for sure that these are parallel is simply because this and this are the same, okay? The reason we know that they're parallel because of that is we have this line going through here, so we'll call it line GD, okay? And both lines are hitting it at the exact same angle because look, it makes the same angle. It makes 44 degrees. So that means these 2 lines are moving in the exact same angle, okay? Because they hit that common line at the same angle, okay? So the reason we know that they're parallel is those 2 angles are the same. And those 2 angles we would call corresponding angles, okay? So corresponding angles are the same angle, just around a different vertex. So what that means is, let me erase some of this so it's not so cluttered. So around this B vertex, this is the top right angle. Around this C vertex, this is also the top right angle. So they correspond to each other. They're both top right angle on their vertex. So corresponding angles are the same angle on different vertexes. Okay. So we have lots of corresponding angles here. We also have this angle right here would correspond to that one, right? They're the exact same angle. This angle corresponds to this one. And this angle corresponds to this one, okay? So the greens correspond, the reds correspond, the blues correspond, the blacks correspond, okay? And they're the same angle, so that means they're congruent. Remember our little symbol for congruent, equal sign with a wave, okay? So those corresponding angles are congruent to each other. So if we have corresponding angles that are congruent, the lines are parallel, okay? So what could you do to prove that the 2 lines are parallel? Prove that the corresponding angles are congruent, right? So corresponding angles, should draw a picture, angles are congruent, using all kinds of symbols here, are congruent. So the lines, so we'll name the lines even. It's line AE and line HF are parallel. Remember, it's two little lines. It looks like two L's, okay? So because the corresponding angles are congruent, the two lines are parallel, okay? If they were not congruent, even if this was 43.999 repeating, they would not be parallel. It would mean that they were going at slightly different angles, and at some point they would run into each other, even if it was a really long time from now, okay? All right, so let's look at all these definitions we have and kind of practice, okay? So we had our 8 angles here around 2 different vertexes. Here's this vertex, this vertex. Instead of naming the angles with letters, I just gave them numbers, so it's a little easier to name them quickly, okay? So if we're talking about, let's start with vertical angles, okay? So vertical angles, you spot them because they're across from each other, okay? In this case, an example would be 1 and 4, or 5 and 8, or 2 and 3, or 6 and 7, okay? All of those are vertical angles, okay? And what is true about them is that they're congruent. They're the same as each other, okay? Corresponding angles are the same angle, different vertex, okay? So if we're going to do corresponding angles, we'd have 2 and 6, or 1 and 5, or 4 and 8, or 3 and 7. And again, what's true about them is they're congruent, okay? Then we have supplementary and we have complementary. Supplementary, no, is the 180 one. Complementary is the 90-degree one, okay? So supplementary, we're looking for that straight line that's been cut, okay? And complementary, we're looking for that right angle that's been cut. On here, we have some supplementary. We don't have any complementary, right? But supplementary would be like 1 and 2, or 3 and 4, or 1 and 3, or 2 and 4, same down there, okay? So those are our different types of angles that we know at this point, okay? And knowing this information is helpful for being able to find missing angles. All right, so perpendicular lines, we talked about parallel lines, now we have perpendicular lines, is 2 intersecting lines that form a right angle, okay? So 2 intersecting lines forming a right angle, okay? Are there still vertical angles? Absolutely, because if that's 90 degrees, this is 90 degrees, and this is 90 degrees, and this is 90 degrees. There's also supplementary angles, right? 90 plus 90 is 180. Are there complementary angles? No, unless you were to cut one of these right angles in half with something, okay? But with perpendicular lines themselves, there's no complementary angles, but there's still vertical angles. The angles across from each other are both 90. They're still supplementary because these two add up to 180, add up to 180, add up to 180, add up to 180, okay? All right, so let's use all of our information to figure out the missing angles. So notice this, it says this figure is not drawn to scale. It tells you that these two lines are, this is a new symbol, make sure to write the symbol down, perpendicular. Okay, so remember perpendicular forms a right angle. So go ahead and pause it and try to fill in all the missing angles and hit play to check your work. All right, so obviously this is 90. So the angle across from it is 90 because they're vertical angles. If this is 34, the one across from it is also 34. And we know that this whole part here has to equal 90, okay, because it's across from this other 90 here. So if that's 34, this has to be 56, and this is also 56, okay? So make sure you're thinking of the reasons why all of these are what they are as you're going through what the different angles are. All right, go ahead and pause it and then fill this in and then hit play to check your work. So if that's 62, this is 62 because of vertical angles. If this is 62, this is 118 because it has to be supplementary, add up to 180. And this is also 118 because of vertical angles. Then over here it tells us they're parallel. So if they're parallel, all the corresponding angles are the same. So everything's the same as the ones up here. Ta-da! Okay, so we use vertical, supplementary, and corresponding angles.